Hey guys, what's going on? So today we will be going over some trigonometry. Uh, Trigonometry is it's a really important topic. Debatably, I'd say it's the most important topic you learn in geometry because it's used again in future math courses. Um, Trigonometry itself actually used to be an entire course on its own in high school years ago, before pre-cal was introduced. And before we get into trig, I just want to go over identifying sides relative to an angle. Okay, so when we're doing trig, we're going to use these three words a lot, talking about sides, hypotenuse, adjacent, opposite. The good thing is hypotenuse hasn't changed since you very first learned what that word is. It is your biggest side on a right triangle. It is the side right across from your 90 degrees. That has not changed. So on all of these, the hypotenuse is the same. Biggest side right across from the 90-degree side. The only ones that can change depending on your perspective, okay, would be opposite and adjacent. So on all these triangles, we're going to be looking relative to this little swoosh here. Okay, so basically we're looking from this angle's perspective, and from this angle's perspective, which side is opposite and which one is adjacent. So opposite, when you're looking relative to this angle here, it's just the side directly across from it. This is the opposite side, and the one right next to it, or adjacent to it, is the adjacent side. The one that's right next to it and not the hypotenuse. Okay, so on this one, boom, here's our opposite side. Here's our adjacent. On this one here, we have this one's the opposite, and this one's the adjacent. Okay, so that's just to go over that because you're going to need to know how to do that in order to even begin doing trig. So this is just kind of fundamental. So trigonometry is the study of triangle measurements. Okay, so everything dealing with triangles essentially is what trig is. Their sides, their angles, and how they relate to one another. That is exactly what trig is. And it is incredibly useful. It is used all over the place. There's even a lot of jobs in real life that require trig all the time. Okay, there's different types of trig functions, or trig ratios also we could say. We go over the three main types. There's 6 and their inverses. If you include their inverses, you could say 12. But at the base level, really, there's 6. We just cover the main 3. Okay, so we have sine, cosine, and tangent. So sine, to abbreviate what these sentences are saying, sine is the opposite over the hypotenuse. Okay, so let's go to the right-hand side and fill out those bullet points. The sine of A. So all these capital letters, typically in trig, your angles are denoted with these capital letters, and then our sides are going to be indicated with the lowercase letters, as we can see right over here. Okay, so it's saying sine of A. So A is right here. Okay, so relative to A, okay, sine is opposite over hypotenuse. So I guess firstly, let's label the hypotenuse because that's going to be unique to the triangle. And then it doesn't matter which angle's perspective you're looking from. Right across from 90 degrees is our hypotenuse. Now, relative to A, okay, angle A right here, little a is the opposite side. So A over C, opposite over hypotenuse. That is sine of A. So that's what we'll put. So it is little a over little c. For B, okay, again, sine of b, so opposite over hypotenuse. So opposite of b is little b, and our hypotenuse is still c. So we got b over c. Cosine is your adjacent over your hypotenuse. Okay? So let's look for cosine of A. A is right here. Okay? The adjacent side relative to angle A is B. And you can kind of do that by process of elimination. We know C is the hypotenuse and A is its opposite. So the only one left really is B. That kind of has to be the adjacent. But again, it's also the side right next to A that is not the hypotenuse. So we could say the cosine of A is B over C. So again, for cosine of B, okay, the adjacent side would be A, and then hypotenuse is still C. So A over C. Tangent. So tangent is a pretty special function, pretty special sign relationship, and it is opposite over adjacent. So tangent is actually the only one where you don't need the hypotenuse at all. You just do opposite over adjacent. You don't need the hypotenuse at all. Okay, tangent of A. Okay, so A is right here. Okay, so tan of A is going to be, again, opposite over adjacent. So A over B. Tangent of B, if we look at B, that's opposite of B is B, and then its adjacent side is A. So B over A. Okay, and there's a lot of patterns. If you look at this a little more closely, okay, there is a lot of patterns you could notice here about the sine of A versus B, cosine of A versus B, tan of A versus B, but we don't dive into a bunch of that. We mainly just want to make sure you understand the basic ratio. Okay, a mnemonic tool to help remember these trig functions is SOHCAHTOA. Okay, so sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let's go through, and for the sake of time's sake on the video, we'll skip 2 and 3. We'll just look at 1. Okay, so it wants the sine of A, cosine of A, tangent of A. Okay, A is right here. Okay, 13 is my hypotenuse. Okay, it's right across from 90 degrees. It's my biggest side. Okay, and relative to A, 5 is my opposite, 12 is my adjacent. So sine of A, opposite over adjacent, that's just 5, or opposite over hypotenuse, that's 5 over 13. Cosine of A, that's adjacent over hypotenuse, so that's just 12 over 13. For tangent of A, it's just opposite over adjacent, so 5 over 12. Okay, going on to the other column. Now we're looking from the perspective of angle C. So angle C is right here. Okay, so now 12 is my opposite side and 5 is my adjacent side. So it just switches. So sine of C, so again, that's going to be opposite over hypotenuse, so this is 12 over 13. Cosine of C, adjacent over hypotenuse, now we got 5 over 13. tan of C, opposite over adjacent. So now it's 12 over 5. Okay. Now to get into actually calculating things. So first of all, if you are asked to round, okay, you'll have to actually input the trig function in your calculator. So if you're using the Inspire, there's a trig button here. It opens up all of these options, okay? You can ignore these last, well, really 6. We're not going to use those in the course. And specifically today, we're not looking at the inverses. So we're just looking at sine, cosine, tangent. Another thing is to make sure your calculator is in degrees mode, which you can do in the settings. And make sure your calculator is in degrees mode. Degree mode should be the default setting, but it doesn't help just to double check, especially before you begin an assessment. Okay, so now actually using trig, that was all an introduction. Now actually using it to, well, find stuff, as we always do in math class. Okay, on all of these, basically you're just given some stuff about a triangle, and then it wants you to find stuff. It's pretty much the epitome of this class. Okay, and notice here too, in the instructions, it does say that it wants you to round to the nearest 10th. So we're gonna have to use our calculator. There's no real other way, especially not based on the tools we know now, to properly do this without a calculator. You're just gonna have to use it. Okay, so let's look. So it gives me an angle, gives me a side, wants me to find another side. Okay, in this class, whenever you see anything like this, that should pretty much scream to you that you're gonna have to use trig. So first thing is first, look relative to the angle they give you. What sides do they give you? Well, x is the opposite side in this case, and 19 is the hypotenuse. So then you ask yourself, well, which trig function or trig relationship uses opposite and hypotenuse? That would be sine. Sine of, and then let's backtrack a bit. Remember how we had A, C, C? Those represented angles. Okay, your input on these functions are angles. So now I actually have a number for an angle. So I could just say sine of 28 degrees equals, and then opposite over adjacent, so x over 19. So now it's just algebra. Multiply both sides by 19, you get 19 sine of 28 degrees equals x. And now this is a number. This is your answer. This is the exact answer, but it wants you to round to the nearest 10th. So in your calculator, you just input 19 times, or you don't even have to put the times if you don't want to, sine of 28, okay? And round to the nearest 10th, so that's 1 decimal place. So that should give you that x equals 8.9. Or to be more accurate, yes, really, you should say x is approximately 8.9. And just for a little joke, this is the difference between a mathematician and an engineer. Mathematicians usually like very exact answers. Engineers always round. They're like good enough for real life, and typically that's true. Both trains of thought are valid. Okay. Again, for the time's sake of the video, I'm just going to skip to 5. Okay. So relative to this angle, I'm given the opposite, and x is my hypotenuse. Okay, so which trig function deals with opposite and hypotenuse? That would be sine again. Sine of 33 degrees equals 15 over x. So I'm trying to isolate x. So I move the x over. Okay, but I need to isolate x, right? trying to find out what x is. Well, sine of 33 is just a number. So if I had said something like, if 3x equals 15, you know, what is x? And then you obviously would just divide the 3 over. Sine 33 is still a number. It follows the same algebra rules. So you can still just divide that over. So now you have x equals 15 over sine of 33 degrees. Okay, so just put that in your calculator. 15 divided by sine of 33. And that gives you that x is approximately 27.5. Okay, that is it for this video, guys. Thank you.